Good afternoon and welcome to another of Tim's Tech Talk videos. Today I'm going to be looking at the electrical system on a 150cc Venom ATV. And this is actually my ATV, which is well loved, and living in the country, we've had lots of fun with it. So what I'm going to do today is to examine the electrical circuit on this bike and run through some troubleshooting tips and tricks with it. Now, whenever you look at this ATV, or any other ATV for that matter, the manufacturer is always going to be kind enough to supply you with this. And this is an electrical diagram for the 150cc that we just looked at. And when you look at the electrical diagram, as you'll see, for example, in the owner's manual, or you can also find this online, I've posted it for you in a slightly exploded manner, if you will, so it's easier to read. You'll notice that the wiring diagrams always indicate sort of the relative position of various parts. So you can see the ignition coil, the CDI, the magneto, where the electricity for the bike is being generated. And then you'll see things like the battery, and then a variety of loads that the electrical system is supplying. Now, electrical diagrams are kind of handy, but sometimes a little bit confusing, because they will show you, for example, where a part is and what wires run to it. But it doesn't really explain how the electrical system works. So when we're looking at this, for example, if I were to have a look at the CDI, I would see that there's a white-black wire running from the CDI all the way over here to the kill switch. But it doesn't tell me, how that affects the CDI or how that works. And this, for example, is the kill switch, which basically would take the CDI charge and allow it to go to ground, which would then shut off the ignition system, and of course the bike shuts down. So you can get some information from an electrical diagram in terms of where the parts are and what different color of wire you'll see going to the different components. But again, it doesn't really explain how things work. So one thing I found very, very handy to do is to have a look at the wiring diagram that came from the manufacturer, and then sort of develop my own little ladder diagram. And ladder diagrams are kind of straightforward because they look like a ladder. And if we can imagine this wire going down as being positive and this wire as being negative, we know we're going to have a 12-volt DC power supply powering up our electrical system. And then the sort of next aspect of this is, well, how's it going to work? Well, somewhere down here, we're going to have a fuse, and this fuse is going to control the amount of power that's available to all of the circuitry that we see in the diagram, so that if we have a short, which means that basically the electrical potential is available to run through the circuit without seeing a load, that's what a short is, then the fuse is going to pop. So what would this look like? In all of our electrical work, we see that there's a variety of loads. And loads are things like lights. And in this particular case, you have two headlights. Now, we already know that these two headlights as a load must have a green wire going to ground, going to the negative side of the battery that we call ground, which also goes to the frame of the bike. So the bike is grounded to the battery on the negative terminal, and this is what we again call ground. So these loads, these two lights, have to have a ground. Well, then the next question is, what controls the lights? There's a switch. And the light switch controls the power to the first light and to the second light. And these would typically be colored red wires, indicating that they come from a positive source. So if you look on the handlebar and you look at the light switch, when you close the light switch contacts, it allows energy to flow to the loads through these red wires, and both lamps are then energized. When you open the light switch, and I'll put a little LS there so we remember it's a light switch, the lights of course will go off. So this is one example of one load in the bike. What's another example? Well, your bike also has a horn. And the horn again is going to have a ground. It's also going to be controlled by a switch. And the switch, when closed, will allow energy to flow from the positive side of the battery to the horn. The horn's going to make some noise because it's allowed to complete its circuit through the ground side of the diagram that you see here. What's another load? An interesting load that you have is the starter switch. So this I'll put an H for horn, and again, starter switch. Now, the starter switch on your bike is kind of neat because it firstly goes through a coil inside the starting relay, and when that coil is energized, it actually energizes a switch, which then allows power to flow through the start relay down to the starting motor. Put an SM there, starting motor, which again has to go to ground to complete the circuit. So this is kind of a cool one. So when you press the starting switch on the handlebar, this energizes the starting relay. The relay has a coil within it. It pulls a set of contacts, makes them close, which then allows electricity to flow to the starting motor. So if the start switch circuit has a problem, that is to say that there is no positive feed here from the start switch, or there's no ground from the start switch, then the coil will not be energized, the contacts will not be pulled up, and this means then that these two large contacts that you see here, which are located on top of the starting relay, will not close, and you will not get any energy flowing to the starting motor. If, however, everything works as it should, when you close the contacts here for the starting relay, it energizes the coil. The coil is now energized, and because the coil is energized, it pulls these contacts closed, and electrical energy is allowed to flow into the starting motor, and the bike rolls over and will start. Now, what's interesting with this ladder diagram analysis is that it allows you to see how things work in relation to everything else. And the first important note is, you'll notice that all of the loads are connected in parallel to each other. Parallel in electricity means that each one of these loads is seeing the same voltage. And that's a very important concept. In your home, you do the same thing. All of the loads are connected in parallel, so everything in your home sees 120 volts AC. The control devices, such as the light switch, the horn switch, the starting relay switch, are connected in series to the load, meaning that the electrical energy must flow first through the control element, which is the switch, before it's allowed to go to the load. So in this case then, all of the switches are connected in series to the respective load that they control. So this is a little bit of the theory behind troubleshooting. Now let's say for fun, I can't get my bike to start and I'm not sure if the starting relay is working. Well, what can I do about that? Let's go have a look at the actual bike. So when we look at the actual bike, the first thing we need to be able to do is define the starting relay. Now I've cheated a bit and I've removed all of the wonderful zip ties. This is a zip tie, and this bike must have 100 of them. So in manufacturing, they like to zip tie the heck out of everything so nothing moves. I've removed the zip tie so I have access to the wiring harness, and after this video is done, I'll go ahead and I'll reinstall some new zip ties. But to share this information with you, this guy right here is your starting relay. And when you look at the starting relay, you'll notice that there's a few wires running in and out of it. The first wire to be aware of is this guy here. Now this guy here is the signal wire. That is to say that when you turn the ignition on for the bike and press the start switch, it allows energy to flow through this connector into the coil and energize the coil. Now, what do those wires look like? A red and yellow, which will be the power supply, and a green, which will be the return or ground for this particular circuit. So when you're looking at the connectors, you'll notice on this side, you have a yellow and red wire connected to a yellow and red wire. And when you're looking at the way that the system is connected up, it's really kind of foolproof because you have a male-female connector. And with a male-female connector, it only goes in one way. And these connections simply clip in together, you can't miss. So this means then that when the start switch is engaged, this connector is energized, these wires are energized, electricity flows down into the start relay and closes the contacts, which then allow power to flow through the upper contacts on the relay, which then send power to the starter. So if you follow these wires back, they go right back here to the starter. And this is the power supply to the starter itself, and this is just a ground to the frame. So if you can troubleshoot yourself through that, you've now corrected any problems in the electrical system for the starting relay. The next thing to have a look at would be lighting and horn. So if we look back at this, we know that the lights have a switch, we know the horn has a switch. Let's go find those on the actual ATV. So when we're having a look at the lighting system on the bike, the lighting is controlled again through this control element. Lights on and off. We follow the wiring down. The wiring harness scoots down here, and we have a few connections here. And again, very straightforward. So these connectors can't be missed. And I just want to film them for you just in case on your bike there's an issue. So we have a great cluster here going into this cluster here. You can have a look and just see the color scheme, right? You can do the same here, and you'll notice that it's very difficult to mix these up because they're different sizes. And it's a male-female setting. So you want to check these connectors, make sure that yours are the same as mine, that the color scheme lines up just as mine does, same as mine, and then have a look over here, and again these black and reds are heading off to where? Well, this guy goes to the indicator switch to tell you that your bike is in reverse. This guy goes to the neutral. So if you shift the bike into neutral, this is the neutral lamp. You can follow it down again, black and red connectors. If we come over here and have a look at this connector feeds over through this wire to your headlight. And you're going to have one on the left and one on the right. And again, you'll see it's hard to misplace this sort of connector because white, blue, red goes to white, blue, red. Red and black goes to what looks to be white and black. Yes, it's a white and black color. And again, you can't miss because there's only one size for these connectors. So again, double check. And we're going white and black to black and red. We follow that through over here again. Same scenario, same scenario. And then the only other difference here is your CDI. So this is where your CDI is located. This is the capacitor discharge ignition system. And if you wanted to soup your bike up, you could do that. You could get a high performance CDI, sort of plug and play. Again, it's a 6-pin CDI. Other points of note, if you're looking to trace back the wiring for your rear lights, brakes, this is the circuit here. You just follow that back again. And literally what it means is removing these zip ties, tracing the wires out, and finding out where things go, and looking for any weak or loose connections. This guy here is your rectifier / voltage regulator. And as we follow again down a little bit further into this area, you can see the starter for the motor, the electrical connections for the starter. And as well, you can see this power supply line, which feeds into an interesting device on top of the carburetor here called a fuel enricher. So these bikes don't have chokes, they have a fuel enricher, which basically allows a little bit of extra fuel to flow into the carburetor when the bike is first starting up. And then once the engine warms up, a port is closed off and the excess feed is stopped. So really handy, neat little device, saves you monkeying around using a choke. Again, moving towards the back of the bike, you can see there's some connecting elements here. And these guys go back all the way to the the tail lights, and also to the battery. So when you're looking at the battery, you're always going to have a main fuse, and this again is a cartridge fuse design. If you have any electrical shorts, and we want to spend a minute on this concept of shorts, because people sometimes get confused with what the heck is a short and how did it happen? Electrical shorts occur when you do not have any resistance in the circuit. So what provides resistance? Lights provide resistance, the horn provides resistance, the starting relay provides resistance, measured in the unit ohm. If the electrical charge flowing through the circuit can find some sneaky way to avoid going through the load and go directly to ground, this is what produces a short circuit. And a short circuit then means that the electrical charge can work through the circuit without having to do any physical work on a load, causes all kinds of current flow, and will cause the fuse to pop. So, do lights develop shorts? Sometimes. Horns? Sometimes. Starting relays? Yes. If the coil inside the starting relay snaps open because it has overheated, some of this coil, for example, will make its way to ground, offering less resistance than normal. This allows huge amounts of amperage or current flow through the relay to ground, causing the fuse to pop. So if your bike will not roll over, you've checked the starting relay, and it looks as though you've got power through the coil, but perhaps the relay is not working properly and you're not getting any power to the starting motor, what could you do to positively test that? Well, on top of the starting relay, right here, you're going to have two terminals. One has a large power supply from the battery running to it, and the other has a cable that goes directly from this terminal down to the starting motor. If you were to cheat and use a booster cable, for example, and you only need one, go to the positive terminal on the battery with the booster cable, and then just touch this terminal. If the starting motor engages and rolls the bike over and it tries to start, then you know for sure that you have an issue with the starting relay. If you're looking at any of the other loads here, and these are called non-inductive loads, so that's an inductive load because it has a little motor in it, like a light or a horn. These type of loads can indeed produce a short, but typically it has to do with the mounting area for the light. So sometimes people will buy a new light bulb, they'll screw it in a little too deep, too hard, and they'll damage the connection, and this will produce a short circuit as well. Because anytime the electrical charge can work its way around the load, then rather than go through it, you'll produce a short circuit. So hopefully you found this a little bit helpful. I know at times it seems a little bit of mumbo jumbo, but if you take your time and work yourself through it, the electrical diagram shows you relative positioning for different things. It shows you the color coding for the wiring that you're going to see. It will show you these electrical connectors that you're going to find on the bike that you clip together, and that's all wonderful stuff. But it's the development of a ladder diagram that really helps with your understanding and explains how the circuit works. So one more quick look at the bike again. You can see I've opened everything up for you here, and I've looked at it from the left side. Now we're going to have a quick look here at the right side, and on the right side right here you can see the power supply feeding in to the starter. On the other side, the two ground wires for the starter. Other things of note, we looked at the lighting on the left side of the bike. If we pop over here, we can also see the lighting and the clips right there on the left side of the bike. Here you can see the start switch, and if you follow the start switch down, it'll go to a 4-post connector, which is right here. And again, all you're looking for is to ensure that these are all nice and snug, that the connections are nice and tight. As long as that's the case, you should have no problems firing up this bike, and of course, enjoying the ride. Take care, my friends. We'll see you next time. Bye-bye.